In this video, we're going to look at factoring using common factors and difference of squares factoring. So a couple of terms that we need to remember first. We've studied factors, and a factor is something that multiplies to give a number or expression. So for example, for 2x plus 4, 2 and x plus 2 are both factors, because if we multiply them, we get 2x plus 4. Factoring is finding what all the factors of an expression are, and it's kind of the opposite or reverse of multiplying. It's like undoing the multiplication. Prime, so if we say something is a prime factor, it means that it contains no factors other than plus or minus 1 in itself. So we have, for example, x plus 2 from this example up here is a prime factor because x plus 2 can't be broken down anymore. It's simply 1 times x plus 2. For numbers we call prime numbers, are numbers like 7, which is just 1 times 7. There's no other way to multiply to get 7. So that's prime. Monomial we've looked at, that means an expression with one term. Mono means 1. Binomial, bi, means 2 terms, so x plus 2 from above. And so those are some terms we've already seen. So let's move ahead now. We're going to look in this section at 4 types of factoring. Common monomial factoring, so remember monomial, one term, so removing one common term. Difference of squares, and so difference of squares, if you think back to our special products, is something that looks like x squared minus y squared. Difference means minus, so we only do this with the subtraction between. Complete factoring is when we do the common monomials and any other type of factoring we can, and factor by grouping is when we look at groups of factors within multiple terms. So we'll start with some examples then. So common monomial factoring, we see here 9x minus 3y. There's a 3 common with both of them, and if we take the 3 outside, well, that gives us 3x inside the bracket. And if we remove the 3 from 3y, or divide 3y by 3, we're left with just y. To check and make sure we have the right answers, well, we just do the opposite, which is multiply. So if we multiply 3 with 3, we get 9x, so there's 9x. And 3 with minus y gives us minus 3y. So that's the common monomial factoring. And we see 2 more examples here. We're removing the biggest common factor between all the terms. Difference of squares, and this falls again into this pattern here, and we saw that the special factor then was x minus y and x plus y. So that's a rule that we can remember. So because here we have x squared and 81, well 81 is 9 squared is how we can think about that. Then we get x plus 9 and x minus 9. And again, to check, if we expand it here, we get x squared plus 9x, then minus 9x, and minus 81 when we multiply the 9's. And you notice the middle terms cancel, and you're left with x squared minus 81. If there's a plus between, that rule doesn't work. Complete factoring then is if first we remove all the common factors. So in this case we can take a 5 from both. That leaves us 4x squared minus 9. But 4x squared, that's 2x all squared, and 9 is 3 squared. So now we can use our difference of squares to get 3x minus, or 2x minus 3 and 2x plus 3. Factor by grouping, well, that's where we're going to take these first 2 terms here. So the 2x and the minus 2y, well, they have a 2 in common, so we can take out the 2. Ax minus ay, those have an a in common, so we can take out the a. But now if we look, now both terms have an x minus y. So if we take the x minus y now, we're left with 2 for the first part and a from the second part. So that's where the 2 plus a comes from. And we can do the same thing for example 2 by grouping differently over here, the second example over here. And instead of grouping and removing the 2, now we're going to group and remove the x. But if we remove the x from the first 2, we're left with 2 plus a. If we remove the y from the second 2, we're left with 2 plus a. Notice here we actually removed minus y. That's where the plus comes from. We divide by minus. Minus minus gives plus. And now we have 2 plus a common, and that leaves x minus y. So you see, either way you group it, we end up with the same result. So we're going to do some examples now. In example 6, we're asked to completely factor. So we want to first take out common factors, and then factor any other way we can. So for 3a minus 3b, we have 3 in both. If we divide 3a by 3, we just left with a. Minus 3b divided by 3 is just b. And so there's that fully factored. And so we'll continue. Common factor between these two is 3x. It's going to leave us an x for the first term and a minus 3 for the second. 5a squared minus 20ax. Well, there's a's in both. 5 and 20, they have a 5, so 5a. It's going to leave a for the first term and minus 4x for the second. Remember, you can always check by just multiplying. Here we see we have a difference of squares. R squared and 25 is 5 squared, so this is going to be R minus 5 and R plus 5. Here we actually have a difference of squares as well, only it's much harder to see. 36 is 6 times 6. A to the 4 is a squared times a squared. So we're going to write 36a to the 4 is the same as 6a squared all squared minus 1. And 1 squared is the same as 1. So we can factor it then as 6a squared plus 1 multiplied by 6a squared minus 1. Same rule, a little harder to see. Same here, 144 is 12 squared. N squared is just n, so 12n minus 169 is 13 squared, so 13. We have p to the 4, so we need p squared. And that means the other bracket is the same, except with plus. X to the 8 minus 1, well, 8 comes from x to the 4 squared minus 1 squared. So we can think about it as a difference of two things squared. So we get x to the 4 minus 1 and x to the 4 plus 1. Now x to the 4 minus 1 we can factor again. That's x squared minus 1 times x squared plus 1, because it is still a difference of squares. And again we see another difference of squares here. So this is x plus 1 times x minus 1 times x squared plus 1 times x to the 4 plus 1. Now we're going to look at some grouping here. So if we look at these terms, we see the first two have a in common and the last two have c in common. So we're going to say that's a outside of m plus n, and this one is going to be c outside of n plus m. But both have m plus n. The order doesn't matter because it's plus. So we're going to take that term into the front, and that's going to leave us a plus c at the end. And the last one, we see 2 pi and r is common to both, so 2 pi r is coming out front. The first, that leaves us n, and the second, we're just left with r. And so there's that factored. We'll do one more example here, since example 7 is short. And we need to solve this for x. Well, we have x in two places, so the first thing we're going to do is collect the x's together. So we're going to do that by expanding here. So nx plus n equals 5 minus x. Collect the x's, we get nx plus x when it moves to the left equals 5 minus n when it moves to the right. And here we have a common factor. So we can take out the x, because that's what we want to solve for, and we're left with n plus 1. So this is why this is relevant. We have factoring here. That's 5 minus n, and now to solve for x, we divide both sides by n plus 1. And we're left with 5 minus n over n plus 1. So that's that answer. These take a lot of practice. Your textbook is full of examples, so make sure you understand these ones. Look at your textbook, try a bunch more, make sure you're getting it. The better you are at factoring, the easier this whole unit is. So I suggest a lot of practice, and if you have any problems, get some help as soon as you can, and we'll see you in the next lesson.